Good morning, guys. Welcome you all to the Self-Help Maths Academy. Today again we will start with the next lecture that is on LU-Decomposition method. It's also called as Cholesky's method. So first we will understand how this method will work, the working procedure of this method. So here what we do here is we consider the system of equation. As you all know, the system of equation can be written as Ax is equal to B. Here A will be called as the coefficient matrix. This the coefficient matrix. Okay, and this coefficient matrix A we will decompose into the product of two matrices, that is L and U. So which are the lower triangular matrix and the upper triangular matrix respectively. So what we did, we have taken the system of equation of the form Ax is equal to B, where A is the coefficient matrix, and in this method we will decompose this A into the product of two matrices, that is L and U, where L is the lower triangular matrix and U is the upper triangular matrix. It is upper triangular matrix respectively. Okay, then what we do? So we will start with the procedure. Then here the diagonal elements of L or U can be unity for the convenience. Either I can take the diagonal elements of L as unity, or I can take the diagonal elements of U as unity as per our convenience. Okay. So now we will start with the procedure. So let's start with the procedure. Let me consider my matrix A is the coefficient of matrix. Let me take this as A11, A12, A13, A21, A22, A23, and A31, A32, A33. And we have to express the matrix in the form of, as I already told you, that this matrix can be written as the product of the upper triangular and the lower triangular matrix, and either L or U matrix diagonal elements I'm going to take it as unity. This is for our convenience. So let me split it into the lower triangular and upper triangular matrix. First, I'll write the lower triangular matrix L11 0 0, L21 L22 0, and this is L31 L32 and L33. This is our lower triangular matrix. Now I'll write the upper triangular matrix. So as I told already that the diagonal element has to be equal to 1. So it is 1 U12 U13. Here it is 0 1 U23 0 0 1. So this is our upper triangular matrix. This is L and this is U. So where A I have expressed as L into U. So this is our first step. So once we have done with this first step, now next what we do? We multiply the matrices in the RHS. So we want to multiply these two matrices now. That is the matrices multiplication, you know, that is the first matrix row into the second matrix column I'm going to multiply. If I do that, it is L11 into 1, that is L11 here, and remaining elements will be 0 into 0, 0 into 0. Second element will be L11 into U12. So here it is L11 into U12, and remaining again this is 0 into anything will be 0. Third element is L11 into U13. L11 into U13. Remaining elements are 0. Okay. Similarly, you can multiply here the next elements L21 into 1, that is L21 here, and L22 into 0 is 0. So again 0 into 0 is 0. So the first term. Similarly, you can multiply the remaining term. You will be getting here L21 U12 plus L22, and similarly you can multiply this with the third row. You will be getting here it as L21 U13 plus L22 into U23. The last term is 0. Similarly, the third column you can write. This is L31 and this is L31 U12 plus L32. And similarly, L31 into U13, L32 into U32 and L33 into L33. So this is the whole matrix you'll be getting. Okay. So once you have got this matrix, so I'll tell you what is the next method. So here equating the corresponding elements on both the side. So here you can observe that I can equate the corresponding element. This is my first element. I can equate with this. The second element I can equate with this. And in this way, I'm equating the corresponding elements of L and U from, L into U from this. So hence A is equal to LU. Let me take this as equation 1. And you already know that your AX is equal to B. Ax is equal to b. So what is A is equal to? I have written it as L into U. It is equal to b. Okay. So or this can also be written as L into Ux, which is equal to b. So this is your equation 1, and LU, A is equal to LU, or you can take this as your given equation, and you already know that A is equal to LU. This is your equation number 1. Okay. So here I'll be considering this is equal to L into Ux. Let me take this as equation 2. Now I put ux is equal to say y, then this equation 2 becomes ly is equal to b. So here from this you can calculate your y, because you know b and you know l, so you can calculate your b, hence y can be found by this equation. So you can calculate y here from this equation. Then by putting y in this equation, okay, so by putting y in this equation, here you know that this equation you can put here y and you can find out the next value. So here putting y in ux is equal to y, ux is equal to y. In this equation if you put, because your what is your ux is equal to, this is equal to y, if you put this value here, you will be getting x, because upper triangular matrix is known, y value is known, therefore we can find out the value of x. This is how the procedure will work. So now let's understand the same procedure with the help of example. So how do we do that? So here this example says list LU decomposition method to solve the following system of equation. So this is what they're asking. So now let's solve this particular system by using the LU decomposition method. So here, when they specifically mention LU decomposition method, we are supposed to use LU decomposition only. So here, what is the coefficient matrix? The coefficient matrix A is equal to, this is 2, 1, 4, 4, 11, minus 1, 8, minus 3, 2. Okay, and what is our x matrix here? X is, that is the variables x1, x2, x3. And what is the matrix B? So matrix B is this constant matrix, that is 12, 33, and 20. Okay, so as you start with, we can write our A as uh, the lower triangular and upper triangular matrix, A as L into U. So we will write that. So this will be equal to here L11, 0, 0, L22, L23, this is L1, L21, L22, 0, and this is here L31, L32, L33, and into this is 1, U12, U13, this is 0, 1, this is U23, this is 0, 0, 1. Okay, so this equal to your matrix A. I've done here. Okay, so like this we will write, and then you know already that we are writing this as the by multiplying this L and U, I'm getting this particular matrix, and this is my matrix A. Now what I do here is I'm going to equate the coefficient corresponding elements on both the side. Here you can see clearly L11 is equal to 2. From here I clearly get L11 is equal to 2, and from this I'll be getting here L11 and into U12 is equal to 1, and similarly here uh, L21 is equal to 4 and L31 is equal to 8. Similarly, all coefficients you can equate. Here you can see L21 U12 plus L22. This is equal to 11. And similarly, this term, that is L31 U12 plus L32. So L31 U12 plus L32 is equal to minus 3. So let me take this as a set of one equation, and similarly I will take this coefficient is set of another equation. So we will solve by knowing whatever the known things are there. By using that I can solve the unknown stuff. Here you can see clearly from this set of first equation, here I know L11. So from this I can calculate U12. So that is U12 is equal to 1 upon L11, which is equal to 1 upon 2. So I've got U12 is equal to 1 by 2. Similarly, now I can see this equation. Here L21 is known to us, and U12 I have already calculated from the above. So I calculate L22 from here. So what I do here, L22 will be equal to 11 minus L21 into U12. This is equal to 11 minus L21 is known, that is 4, and U12 is also known, that is 1 by 2. 2 ones are 2 twos are. So 11 minus 2, it is 9. So L22 I'll be getting it as 9. So from here I've got L22, and from here I've got U12, and again by using this L31 is known to us, U12 already we found. So L32 we can find out. So like this you can find out L32. Okay. So here let's see, L32 will be equal to minus 3 minus L31 U12. This is equal to minus 3 into what is L31? It is 8 here, and this, I think this is minus 3. Here it is minus uh, 8 into what is U12? Already we found it is 1 by 2 here. So 2 ones are 2 fours are. So it is minus 3 minus 4, it is minus 7. So like this we are able to find out the different, I mean all the unknown values. So like this I am finding out, see, L1, U12 I found, then L22 we found, then L32 you have found. So once you have found this, then by using the equation 2, so clearly you can find out L11 is known to us. You can find out U13. U13 will be 4 divided by L11. L11 is 2. It is 4 by 2 means it is 2. Similarly, from this equation, I have taken here, see, L21 into U13. So correspondingly, I am finding out all the unknown values, that is U23, and I am finding out L33. Now all the values are known to you. So you can just now write the L and U separately. So what is L matrix? It is L11, 0, 0, L21, L220, L2, L31, L32, L33. So like that, U is 1, U12, U13. This is 0, 1, U23, and similarly 0, 0, 1. So I've got the matrix A and sorry, the matrix U and the matrix L. So already we know that A is equal to L into U. Now let's apply the, once you got A, L and U, the half of the work is done. So now what we do, we'll use the simple procedure for further calculation. That is, consider Ax is equal to B. Now, as you all know that what is A is equal to, it is LU into X is equal to B, or you can write this as L into U of X is equal to B. So this is all known stuff, and we will take now ux is equal to say y. So what about our equation becomes, this equation becomes L y is equal to b. Okay, so now use L is known to us and y is known to us and b is known to us. I mean, what I'll do here, this is my L, that is 200, it is 490, and it is 8 minus 7 minus 21. This is our L, and y is y1, y2, y3, and which is equal to what is b, it is 12, 33 and 20. Okay, so now simple, you can just see that this is the upper triangular matrix. From this 2 into y1 I'm getting here, see 2y1 is equal to 12. From here it is 4y1 plus 9y2 which is equal to 33, and similarly from this it is 8y1 minus 7y2 minus 21y3 is equal to 20. Okay, so by using the substitution method, now from this I get y1 is equal to 6. By substituting y1 value from this above, I'll get y2 value. Similarly, from y1 and y2 value above, if I substitute here, I'll get the y3 value. So like this, by using the back substitution method, I'm calculating the value of y1, y2 and y3. See, y1 value is 6, y2 will get as 1, and y3 you will get as 1. Okay, so once you've got y1, y2, y3, now the simple calculation is left, that is for x. So how do you do that? So you know that your now you know that this particular, from this equation you can see your Ly is equal to b, but ux is equal to y. Already y is known to you, u is known to you, u is known to us, and y is known to us. So I can find out x now. So now consider u into x is equal to y. So what is u? U is upper triangular matrix, that is 1, 1 by 2, 2. This is 0, 1 minus 1, 0, 0, 1. So into, I consider this as x1, x2, x3, which is equal to y1, y2, y3. y1 is 6 here, y2 is 1 here, and y3 is 1 here. Okay, so once again, this is x1 plus 1 by 2 x2 plus 2 x3 is equal to 6. Again, this is x2 minus x3 is equal to 1, and from this it is x3 is equal to 1. So from x3 is equal to 1, if I substitute x3 is equal to 1 here, you'll be getting the x2 value. X3 is equal to 1, if I substitute, x2 will be equal to 2, that is x3 is equal to 1, here x2 is equal to 2, and similarly if I substitute x1, x3, x1 and x2, that is by back substitution method, if I substitute x3 and x2 value in this, I'll be getting x1 as 3. So this is x1 as 3. So therefore the value of x1, x2, x3 is 3, 2, 1. In this way, we're going to find out the value of x1, x2, x3 by using the decomposition, the LU decomposition method. or it is also called as Cholesky's method. So simple. What is the hint you are supposed to remember here? You have to first you have to write your A as L into U as the product of L into U. Then as you know that your AX is equal to B, you're considering what is your A is? It is L into U into X is equal to B. The same thing can also be written as L of Ux is equal to B. Let's consider Ux is equal to Y, that is Ly is equal to B. Okay, so already Ux is equal to Y. Also, you know, you start with Ux is equal to Y. Once you find out A is equal to Lu, from this you have got L and U separately. Once you have got this, then take Ux is equal to Y. You take Ly is equal to B because L is known to you, B is known to you. You can find out Y value from this. Once you got Y value, consider this equation because upper triangular matrix is known to us and Y value is known to us from this previous equation. So thus what we can calculate? We can calculate the value of X. This methodology we call it as LU-Decomposition method or lower triangular, upper triangular decomposition method. So this is one of the important method one should know in the system of linear equation, solving the system of linear equation. Okay, so with this guys, you have to solve some more questions. I'll just try to solve some more questions, guys. I'll just give you one example. I just give you one more question here. This example you try to solve yourself. If you not getting any solution, anything, please comment in the box so that I'll get back to you with the solution. This is how you have to deal with the LU decomposition method. In the next video, we will deal with the next concept. Till then, take care, guys. If you like the video, please subscribe and comment for the better for the next videos. And please feel free to ask your questions and get back to me if you have any doubts. Thank you so much, guys. Take care. See you all in the next video.